Okay. So yes, good morning to everyone again, and it's a pleasure to present to you guys here today. I hope that everyone has been keeping safe and healthy during these very recent and unprecedented times. So thank you also again to PV Box for arranging the webinar, and very excited at the opportunity to share some of GoodWe's insights and strategy into the South African energy storage sector, amongst some of these other esteemed presenters here today. Maybe just if I can start off with a little bit of context about GoodWe, and that might give an idea of how we fall into the storage sector in South Africa. And then, yes, well, after the context, I will give you a bit of PV market data and show how that translates into the storage market sector for South Africa. And we do have limited time with our presentation, so I won't get too much into detail about the data itself, but we can then offer more detail in the Q&A section after the presentations. So GoodWe is a top 5 global PV inverter manufacturer, which is headquartered in Suzhou in China, and that's where our manufacturing facilities are. It also has, GoodWe has a very extensive portfolio of grid tie, hybrid, and storage inverters, ranging from 700 watts all the way up to 250 kilowatts. And a very brief update on the slide. So recent update is GoodWe has recently hit 13 gigawatts of inverter supply globally, and that's a cumulative number. And GoodWe has approximately, well, slightly more than 1,000 employees globally, of which 200 of those employees are R&D staff. So as you can tell from that, R&D is a very critical aspect of what GoodWe views as a strategic advantage, and is very much represented in the robustness and the reliability of the products we bring to market, and also very much attributed to the market share growth that GoodWe has seen since it was founded in 2010. And then just a very broad overview. So GoodWe has a very big global presence, of course, a very big presence in China, but other important markets such as the Netherlands, Germany, the UK, also South Africa, of course, South and North America, and Australia. And out of those markets, China for GoodWe is for distributed PV in China. GoodWe has #1 market share. Same thing in the Czech Republic. And #2 for distributed PV in Australia. And then also very strong presence in some other markets. For South Africa specifically, in the energy storage sector, so focused on hybrid inverters, GoodWe recently achieved #1 in terms of market share for South Africa, but we're definitely looking to strengthen that quite substantially. And it's also, well, at least from my side, an impressive achievement, considering that GoodWe hasn't been in the market in South Africa for as long as some other competitors. Okay, and then a broad overview on just the quality, and again, this very much translates into the big and strong R&D team for GoodWe. So TUV Rhineland have an All Quality Matters Award. It's an annual award specific to inverters, and GoodWe has won this award for, it's now 5 consecutive years. We just received the announcement last week, very recently, so that hasn't translated into updating the slide. But for 2 inverters, we received the award again, the latest award for 2019. So that's 5 consecutive years, and GoodWe is the only inverter manufacturer who has achieved this feat. So something that we are quite proud of. And then just a brief overview of the product portfolio. So in this slide, we can see these are the storage products, or hybrid products and AC retrofit products, starting from 2.5 kilowatts all the way up to 10 kilowatt 3-phase. These are all battery related, both low voltage and high voltage. And then a recent development for GoodWe is a C&I focused, or commercial and industrial focused, storage product, which we will be introducing to market by the end of the year. And that's going to be from 50 kilowatts in modules of 50 kilowatts up to 200 kilowatts. So we're very excited about that. And then we move over to our 3-phase product portfolio for commercial and industrial, and also transitioning into utility scale products. So yeah, we start off at 10 kilowatts. Currently in production, we have up to 150 kilowatt units, but also, as mentioned before, we have a 250 kilowatt product in development. And then related to storage and our hybrid inverters, very much related to that is battery compatibility. So here's a brief illustration of the global battery inverter manufacturer brands that we have aligned with, both low voltage and high voltage, and very important and very applicable for this webinar. And it's a recent development is Solar MD. So Kalo Yan, who's also a presenter here today from Solar MD. We've been working very closely with him and his team in South Africa, and working very hard with them to become an official global compatibility brand. And the official promotion of this collaboration with Solar MD will commence in August. We're just in final stages of that testing. So fantastic development from GoodWe's side for the South African market. Okay, now getting into some of the data that's maybe more related to GoodWe and our involvement in the storage sector into South Africa and Africa. So you'll see 2 illustrations or 2 tables on the screen. The top table is for the African PV inverter market, the data and the forecast. So this is from 2017 up to 2020. And the source of all this data, by the way, is IHS Markit, and this was their latest analysis from 2019. So some of these numbers, of course, in the 2020 forecast and beyond up to 2023, will likely be different considering COVID and the impacts of COVID on the economy obviously changes these forecasted numbers. Yeah, it's you can see how the sectors are divided into off-grid, residential, small commercial, medium commercial, large commercial, and then small and large utility scale. And in Africa, as you can see by those numbers, large utility scale for PV has definitely been the predominant sector, but we do see that we have been seeing that shift quite a lot, as you can see in the table at the bottom. So those are the PV installations by system type in Africa and the Middle East. Specific to South Africa, we can see that the off-grid market in 2019 was approximately 37 megawatts in South Africa. The residential sector was 48 megawatts and the small commercial was 78. Now, again, keeping in mind this data is specific to PV. So the reason I highlighted in yellow, the reason I highlighted those particular numbers is because PV also correlates very closely with energy storage and where we are seeing energy storage growth. So PV and storage are going hand in hand, especially with those market sectors. So residential and small commercial is the majority of the traction that we have seen with GoodWe and our products. But that's definitely escalating into the larger market sectors. And I think Kayla Yan will have a lot more information on what they're seeing with their utility specific products. So yeah, and there's definitely a dynamic shift occurring in the market for sure. And then for South Africa, the storage overview. So South Africa has a very unique storage sector market in that it is not driven by formalized financial incentives. And you'll, definitely in my past and the markets I've been involved in, the PV markets in developed, let's call it developed nations, those markets are normally initiated and stimulated with incentives. In South Africa, and into Africa in general, is quite different in that the growth is it's not stimulated economically; it's stimulated organically. So it's stimulated by the consumer's business case and load shedding. In South Africa, of course, load shedding is a big driver for the growth that we're seeing in storage. And there is a tax benefit for PV consumers in South Africa, but that tax benefit is only specific to PV, and it's not specific to storage related products. And I think we could definitely use some advancement in South Africa in the storage sector in that regard. But regardless of that, the growth is still occurring very organically. And there are definitely many advantages in the storage market which can be addressed. So at the moment, it's the storage sector has been addressing the organic need. But in terms of progress, and I'm sure Kayla will elaborate more on this in his presentation, but smart storage and smart grids are a next evolution that could definitely help South Africa with its network and also complexities in the current generation and supply. And so for GoodWe, South Africa is GoodWe's largest storage product-related market globally. Again, to date, a majority of GoodWe's revenues in South Africa have been storage inverter product-related, even though GoodWe has a much broader portfolio of products. Our storage products or hybrid inverters are, what's really driving our growth in South Africa. And this is purely based on market demand, with no financial or no official financial incentive offering for that sector. So that's a great thing about South African market for us. And then some storage challenges So we have definitely have because you could almost say that the storage industry in South Africa is South Africa's newest and latest gold rush to a large degree, because it is a very fast and rapidly growing market sector. So with that, there has been somewhat of an education and skills gap. That being said, there are many very competent and credible companies in South Africa, EPCs in particular, who are very dedicated to PV and also to the storage sector, and are extremely competent. But with this new gold rush, it's also bringing in a lot of companies that are pivoting into solar because of the opportunity that they see, and especially in our limited and dwindling job opportunity market in South Africa, especially given COVID recently. The solar and the storage market attracts unskilled or new installers who often lack the skills required for effective installations. And this sometimes puts a little bit of a dent in the reputation of the industry. But where we could benefit is by establishing more rules of engagement. So, more official policies and regulations that will help offset this and also help to really strengthen the storage market in South Africa. And then, incentivizing storage, to enable and balance the network in terms of peak and base loads, etc. I think will also be, it won't only incentivize the growth of a very up and coming industry, but at the same time will also incentivize, our grid network in being able to handle the pressures of the generation. So yeah, and that's it from my side. Thank you very much for the opportunity of being able to present with you, and looking forward to any questions that may come up in the Q&A portion of the webinar. And with that, I'll hand it over back to Terry.
Thank you very much. It's very encouraging to hear your progress in South Africa and your fantastic quality of products and the collaboration you've been having within South Africa, and the advancements of the technology and where we're going. Could I perhaps now ask for Mondi to take over and present his presentation with a brief introduction, and then we can pick up after that with some questions. Mondi, can I hand over to you right now?
Yes, thanks, Terry. Please let me know when you can see my screen.
Okay. There's a little bit of a lag on the line, but there we go. I can see your screen now. Thank you.
Right. Okay. Good morning, everybody. My name is Monde Sonia. I'm with Eskom as my employer currently. I have a couple of roles that I am currently playing, and one of them is with SAIE as a counselor there. SAIE is the Institute of Electrical and Electronic Engineers here in South Africa, and I lead a working group internally at Eskom that is responsible for the developments within energy storage, currently just focusing more on battery energy storage. So what I'm going to share with you guys today is a framework for technical network studies to be performed when one is looking at integrating energy storage into the power system. So the context of my presentation is mainly power systems application of the energy storage. So this is basically the bulk energy storage, as it were. Now, in terms of the context of my presentation, if you look at the life cycle, you know that you start with the planning and you go all the way on any project, you end up with operation. But for today, my focus is mainly on the planning stage of the project. Sorry, I'll be focusing on the planning stage of the project. Now, the framework that we have, or the framework that we have put together, is a framework that has 5 steps. I will be taking you guys through those steps. So the first one is data collection and review, which is basically just looking at the network topology, what is existing, what is planned in the future, as well as the loading, the network loading, looking at historical data and also the forecasted load. Then the second stage of that framework, we've got local network constraints and local network constraint studies and use case selection. So basically what it means is that you've collected the data and now you want to see what is wrong with the network at a local level. And therefore, you can also select your energy storage use case, so which is your application. You look at the existing network constraint, you look at the you do the simulation of the future constraints. So basically, what is the problem on the network now? What is forecasted to be the problem in future? Looking at voltage, loading, fault levels, and all those technical network operating limits. Then also you identify the best application. So this would be now the actual application of the storage that you want to do. So the third stage, or the step number 3 of that framework, is preliminary best size need identification and load flow study. So basically, you know the network problem that you have. If it's a problem on the network, and now you want to identify the preliminary size, the size that will be sufficient to solve that problem. If the problem is actually on the network, the problem that you want to solve with the storage. And you do this through the load flow studies. I will get into the details just now. Then the fourth one is the best storage model. So sorry, just to explain something again, BESS means battery energy storage system. So when I say storage and when I say BESS, I actually mean the same thing. So the fourth stage is the modeling of the storage itself. So this is the looking at the degradation characteristics, the energy losses, the life expectancy of the storage. So this is more now just looking at the chemistry of the storage mainly. Then the fifth one is the final step, which is to do the power system analysis of the BESS model. So you have a certain storage that you have modeled. Now you want to look at the power system and you want to see how the power system is going to respond when you apply such a storage that you have already modeled. Now, I have on the right hand side here, I've got all those steps, all the 4 of them, so I'll be highlighting each one that I'll be talking about. So I said the first one is data collection and review. Now, the energy storage studies are quite data intensive, so you need to do a lot of data collection and review. So usually we look at 8,760 hourly loading data. So that means each hour in a year, you want to collect data for that, and so that you can study that. And the main reason for that is because of the energy analysis that you want to do. You want to see whether you will have enough capacity to charge and you will have enough capacity to discharge, looking at the efficiencies and all those kind of things. Now then, the last bullet there is on the clustering methods, which can also be used to reduce data intensity. So those are sort of techniques that one can put in place to try and reduce the data requirements, and which also eases the burden on the machine or on your computers in terms of data analysis. Now, the second step on the process I said it's local network constraint and use case analysis. So what's important here is that one must understand the capabilities of the network where the best is to be integrated. You don't want to put a storage in a network and you actually want to derive certain certain uses out of that storage, only to find that that storage will not be, or the network itself will not allow for the application that you want. So let's say, for example, you want to use the storage for frequency control and you put it on a network that is already constrained, then obviously the network will not allow the capabilities that you want to derive from the storage. So you want to understand what capabilities the network has, and then you can select the appropriate use case for the bus at that specific location. Now the next one, which is the third one, just a little bit in a bit more detail, is the preliminary load flow studies. So this is also deriving the size of the battery energy storage that you want to apply. What you are looking at here is the best size that is required to solve the identified problem. Let us say you were looking at a network along line that is overloading, it's in remote areas, it needs hundreds of kilometers of network, a new network to be built so that you can allow for connection of new customers. Then now, if you want to do that, you want to look at what is the size of the storage that is required to allow you to do what you want to do. So that's the first thing that you want to do in terms of identifying the preliminary size. Then secondly, having that size in mind, secondly, now you want to perform some tests to actually to check the network operating limits. It's easy to say I need 10 megawatt, 50 megawatt hours of a storage on a certain part of the network in order to solve my problem. But then there is something else that you want to balance with, which is the network operating limits, which are utility specific, as I've indicated there. So one of those operating limits is what we call RVC. So RVC is the rapid voltage change. Different people call it different names. I've seen SVC, which is step voltage change, and there are a few other terms that are used to mainly define the same thing. And this is utility dependent. Some have got 5%, some use 6%, and I've seen some going as high as 10% allowance on an RVC. So you want to test that. You also want to test the load rejection. What will happen when the storage is in operation and certainly it trips? What would be the impact of that storage when it acts as a load? Then the last one would be the thermal capacity. Will the network be able to, cater for the charging and the discharging? Do you have enough capacity on the network in order to derive what you want to derive from the storage? So I just have here a graph that shows the concept of RVC. For example, you've got your voltage there, your initial voltage. When your storage was operating, let's say, for example, it was injecting power into the network and it trips, then the moment it trips, then the network is going to experience a voltage dip, and then your tap changers, on-load tap changers from the transformers, your voltage regulators, and all those corrective equipments will start to correct the voltage back to some acceptable level. Now, the RVC is that dip that happens, that takes place initially. So you also want to make sure that that dip, if it does happen, it is within the allowed utility limits. Now, then the fourth step on the framework is the storage modeling itself. Remember that I said this is now just focusing more on the storage side, and not really mainly paying attention to the network. So what happens here is that you want to model the bus operation and storage characteristics. Now, this I've taken it from the Dixieland Power Factory manual. It explains the concept better. So basically, you've got your storage control here, which is shown in a flow diagram, just to demonstrate the principle. So on this side, you've got your monitoring side, which is you're monitoring your voltage. It could be monitoring P or Q, which is power or reactive power, active power or reactive power from the network, or it could be frequency, based on the use case that you want to apply the storage for. So all those measurements go into what is called a PQ controller, which then communicates with the charge controller. And now the charge controller needs to communicate directly with the battery stack. And on that battery stack, the SOC, which is the state of charge, has to be monitored, the cell voltage, the current from the cells. And that's where now you also have your characteristics like degradation and your round trip efficiencies, etc. And then the output from that charge controller goes to the converter. And now when it goes to the converter, and that's where you get the actual output. So it could either be the current going out or the current coming in, which means it's charging or discharging. So basically, that is what, in a nutshell, that's what storage modeling really means. Now, the last step that we have on our framework is the power systems analysis. So the critical question here that has to be answered by this step is, will the storage operate safely in all modes without violating the network operating conditions? So this is, now you have modeled your storage using your step number 4 there. Now the question is it safe for the storage to operate on the network in all modes, meaning that when it charges, when it discharges, when it idle, what will happen on the network? How is the network going to respond to that? So there are several aspects that need to be checked. That is the voltage variation band. You want to ensure that when the storage operates, it remains within the safe band of the voltage variation. It doesn't cause issues on the network. And the second one is the thermal loading. Will it cause strain on the network when it charges? Will it cause strain on the network when it discharges? So you're looking at all those evacuation corridors. Are they sufficient or not? So that is the last part of the framework that one has to run. So in terms of concluding remarks, in our context here in South Africa, we mainly have networks that are long, that are radial, and basically that are weak. And secondly, best operation involves converter switching, which is not always good for weak networks, especially, again, if you want to apply it to push back into the network. I think then it becomes a different case if you want to apply it behind the meter as a customer. You want to supply parts of your load. That is fine. That is not a problem. But if you want to use it as a network asset, as to contribute towards the running of the network, then it provides limitations because of the weakness of the network. And the third bullet is benefit staking is a unique feature of the battery energy storage systems. However, it is not always possible due to the limitations on the network strength. So you want to use your best to run ancillary services, but it's sitting on a weak network. When it does fast switching to do frequency control, then it starts to create voltage fluctuations on the weak network, and that now presents a new problem. Basically, all that I want to say is that network capacity upgrade is not avoidable if you want to use bulk energy storage and you want to use it to support or to run the system. You want to allow more cars on the road, you have to widen the road. Basically, you want to have more players on the grid, then you need to widen. You have to widen the grid and ensure that it has enough strength to take all the fluctuations that come with the energy storage. Thank you very much, and thanks for the opportunity to the organizers, and I will wait for questions. Thank you so much.
Thank you very much, Mandi. May I ask you to please put your video on? We didn't manage to see you while that presentation was working, but it was certainly very interesting in terms of the process that you need to go through with the data analysis, understanding the constraints, the siting and the load flow, and definitely that safety is one of the major considerations of Eskom. And as we are speaking to multiple countries, I just wanted to emphasize that Eskom is our only utility in South Africa. There's a very small margin that is independent power producers. So we rely very much on Eskom's grid and the knowledge and professionalism that Mandi has shown us today. Mandi, would you like to add a comment to that before we go on to the next part of the presentation?
Yeah, so I would like to take any questions, but I think we will deal with. There could be more that I can add at the end of the session as we are going through the Q&A. There is quite a few initiatives that are taking place, in terms of from the regulatory front as well, with NERSA. I think we are on the right path as a country. Now the question would be, are we fast enough? I don't know. I think we could actually do better as a country now, and not necessarily as a business, in ensuring that we have all our regulations in place to actually allow for the market, on the energy storage. Thanks for now.
Thank you very much. Max, do we have the slides that we can load up to share? Can you just put that up for us if possible? I'm just waiting to see what happens here. Max, are you able to do that? Okay, it seems that we have a little bit of a delay. Please bear with us. I think in the meantime, if we could possibly have Kalyan ready to respond with some of the issues that Stephen Davey brought up with his presentation, and also the question around the battery energy storage system that Eskom is planning. And being a local manufacturer in South Africa, you could possibly just see how our technology and the advances are going to assist with the base system, as well as the international interest. Okay, it seems I don't have the slides. So Kalyan, are you ready? I'm going to ask you to please take on the presentation and introduce yourself. Seems we don't have Kalyan either. Are you there? Okay. Is that Matt?
Can you see myself and also the presentation? Everything is visible.
Can you put your camera on, please, Kalyan? I don't see you or the presentation at this stage. There's probably a little bit of a lag. Kalyan? Oh dear, have I lost the signal?
No, I can hear you, Terry. It's Monday. I can hear you, so you haven't lost the signal.
Your slides, Kalyan, if we can just put your video camera on so that we can see you as well, please, that would be great.
Okay, can you see me now?
Yes.
Okay. Thank you, Kalyan. If you would like to go ahead.
Okay, my name is Kalyan Dimov. I'm the CEO of Solar MD. I'm also in the solar industry for about 12 years now. I used to work for a big EPC company and built about 200 to 300 megawatt of large-scale PV plants. And 7 years I'm basically doing energy storage and not so much PV, but the energy storage works with the PV. So the company was commercially started in 2014, and yeah, we grew exponentially every year. Maybe. So here is a bit more about what I'm going to talk today. So I will just mention more about the containerized battery energy storage solutions in this presentation. But generally, the energy storage what we manufacture here in South Africa is used for power residential homes, industrial batteries, and we try to develop our solution as smart as possible. So we all our batteries are monitored. We have more than 6,000 systems already, which we monitor. And they are mainly in Southern Africa. So SolarMG has in-house very R&D capability. We do our own electronic engineering. We have own-developed BMS and communication device called Logger V2. We do our own mechanical engineering. All our systems are basically mechanically also developed in-house. And we have software engineering. So the total team of the R&D at the moment is 15 people. They come from people from Europe, Bulgaria, and Spain. We have people from China and African engineers and some of the neighboring African countries also. So it's a very multicultural R&D team. The manufacturing capability, it's also in-house, all the mechanical engineering. We do our own designs. We have bending machines. We have laser welding machines for the cells. And the electronic engineering, it's designed only in-house, but mainly manufactured in a different facility. And yeah, all the software is written in-house. And the facility at the moment, it's about 10,000 square meters, the total production facility in Cape Town. So currently our partners are mainly inverter manufacturers, inverter and PCS manufacturers, and the organizations like Sapphire, Green, and of course Energy Box. So the service. Okay. Can you see me?
Yes.
Hi, Caleb. Yes,
I
you can see your presentation.
It seems to
Okay, something went black on my side. Okay, so the batteries, what we manufacture, or the energy storage solutions, are mainly used for the residential and commercial market. Very wide sharing knowledge with installers. We call this SolarMG Academy. And we do a lot of trainings to installers in-house and also in webinars. We have installation videos also uploaded on YouTube. So also we specialize also in solutions for mini grids, isolated grids, villages in Africa, through partners, but also use our solutions, and we help them to develop the full project. and of course the monitoring, which allows advanced firmware updates and basically artificial intelligence for some of the inverter types which don't have good monitoring and don't support digital communication. And this makes our solution basically to run pretty seamless. I'll mention now about the containerized battery energy storage systems. So we do in-house solutions up to 2.5 hours per container. So that would be typically 6-meter or 12-meter container, 40 foot, which can go up to 2.35 megawatt hours, and it's and scalable solution. So it's made from our standard battery cells, which convert into a SS202 battery module. And then we have battery cabinets, which in a container can go up to 40 of these battery cabinets and up to 240 SS202 modules. So all these solutions, them and pretest them in the factory, and then when they reach the site, they are basically ready to connect. That's how it looks like. A little bit more technical information. So you have to have an external power conversion system or inverter, or so-called PCS, which can range from a couple of 100 kilowatts up to megawatt in the power. So the 14 SS202 are connected in series, and they build a 712 volt DC voltage. There is a DC fuses and contactors protection, then gets connected to the PCS. The PCS can be inside the container, or also can be an external device for a bigger solutions. Let's say if it's let's say 10 megawatt hour solution with 2 megawatt PCS, typically the PCS is in its own container basically. That's the specs of that module. So it's 7.4 kilowatt hours, usable maximum 5 kilowatt discharge current, and the battery life cycle, it's more than 4,000 cycles. It has also CAN communication. A typical PCS system, so power conversion system. We work with a couple of manufacturers, Sangro, Goodwe, and SMA currently. So we trying to adopt more and more PCS manufacturers to our battery solution so that we can offer a full power solution. So that's our monitoring system. I don't know if it's visible, but basically it has a residential dashboard or a commercial dashboard where we can see the load, the PV production, and the battery storage, and then we can drag into the devices and see down to the cell level, temperature of and the cycle life, efficiency, all the software updates and firmware updates can be done remotely, and we can draw graphs for pretty much everything and do real-time fault finding. So these are currently, okay, this is a little bit old. We have also now one system in US, but this is pretty much all systems which are online. You can see that the main market is actually Southern Africa. And we have, as example, in China, we have just one test system. Yeah, pretty much everywhere, small. So this is some example solutions of which were built and are operational. Mainly mini-grid solutions, so there is no grid or a generator integrated into the system, and powering lodges, small villages, or just used as a backup on an existing grid. So here is our estimated market share for 2019. We consider ourselves probably as a market leader. There is the good thing is that there is also other local South African manufacturers which also provide solutions and develop this industry. So I think there is many of the Chinese manufacturers, of course, and some of the European.
Thank you, Kalyan. It was really encouraging to hear the amount of technology and cooperation across the world that is happening with Solar MD, especially also with GoodWe, for instance, and looking forward to your solutions for the battery energy storage system for Eskom as well. I think at this point, could we ask Julian Caballera if he could actually do his presentation? I missed a portion of that, but I should think that you would like to do your full presentation now. What I believe to do, what you did with the introduction earlier on.
Okay.
Julian, are you?
Yes, I'm going to just take the lead. So, okay. Can you see my whole screen right now?
Thank you. We can see you. See the screen?
That's great. Okay. So hi, everyone. So I already started my presentation, so I'm just about now making the presentation. The purpose of my intervention is I'll try to speak very briefly about Energy, but I'm here more about trying to explain the possibilities of storage given for the grid. And I think that presentation will be very complementary with the presentation that Mondi did from Eskom. So I hope that with that presentation, you will have a better understanding about what is possible to do with storage and how to optimize the storage to generate more value for the grid, which is the title of the presentation. So just very briefly, only one slide about Energy, and then I'll move about the subject. Just because we are not from South Africa, we expect, of course. We are a French company. Maybe you can see that with my accent. So we are a French company. We've been founded in 2007. We're at first a pure IPP player. We developed about more than 1 gigawatt of project for solar and wind, and more than 100 megawatt hour of storage project. So I hope that we are not the biggest one. We are not small. We are, let's say, a medium scale company. But the good point of being medium scale is that we are quite flexible. And maybe one of the things that make us unique is that among all IPP's players, we're one of the only that also developed an industrial strategy. I mean, that we built our own storage container, we build our own EMS software. That means that we can be very flexible, and we made many projects with very different specifications, and I'll show you just after the presentation. The other point is that we are very oriented to local content. Just to give you an example, we are number one in the French islands, and because in the French island there is some very specific content. For example, on the storage project that we did in that island, we built the whole container not in front but in the island. So this is typically one of the specificity of Aker Energy, that when we play local, we build local. The other thing is that we are present on the whole value chain. I mean, that is not just about development, financing of construction, but we are also involved in operation. That means that when we build a project, we try to be on a very long-term view, and that makes us a good references and the technological diversification. So that's all for Akio. So don't worry, I'm not going to speak about the company, but just to say who we are. Then when we are talking about the BSS, so Mondi explained what does mean BSS, is battery energy storage system. To be honest, we can't be lost. Why? It's because when we are looking at the applications that provide BSS, there is so many applications. Just to give you a big picture about those applications, we've got what we call energy arbitrage. It's about trying to charge when it is cheap and discharge when it's expensive. But also about all the range of services for the frequency regulation, like the primary response, secondary response, tertiary response. We've got all about picker replacements, the black stuff when we are talking about off-grid. We've got the seasonal storage. We've got the TNB optimization. So it's not about, I agree with what Mondi said. I mean, it's not about grid default, because many people speak about grid default, but I disagree, because whatever happens, the grid has to be updated, upscaled, and so on. The point of putting some storage is just about trying to optimize the load rates of the grid, and that's the purpose of when we say optimization. There is also congestion management. For example, if you put too many storage on one single line, in that case, you may need some storage to optimize the load. You've got some bill management. If you've got, for example, a very high cost of providing power, if you pay a lot in rand per kilowatt and not per kilowatt hour, you've got power quality, you've got power reliability. It's more about UPS. So the consequence is how not to get lost about all the different applications that you can have with storage. So I'll try to make some key lessons about what we understood from the 10 years we are working on that. And I hope at the end of the presentation, you will have a better understanding about what is possible to do. So just to summarize, when we're talking about storage, there is 3 different timescales. There is the timescale about the millisecond, the second, which all the applications that we can put in the family of grid stability. Then we've got all the applications in which you're going to charge and discharge within 1 hour. In that case, it's all about capacity firming. And then when you are talking about storage for more than hours, so we are talking about the day scale, is all about time shift. And in that case, is more about dealing with energy and not only with power. So, I mean, and so there's first the time scale, and then there is the power. I mean that when we are dealing with power at 100 kilowatt, is not the same that we are dealing with storage at 100 megawatt. So if today we are talking about the large scale, which is more than 10 megawatt, in that case, there is many places in which we can put storage. It's not about just putting storage close to a wind farm or a PV plant, but we can also put storage close to conventional source, like a coal plant, for example. Or also it can be pure storage. In that case, we would put the storage in grid nodes, just to be able to make more value with all the applications that we can do on the grid. So the major objectives when we are dealing with big storage system with a large amount of megawatt hour is mainly about enabling HV grid optimization. It's also about performing energy arbitrage, and it's also about trying to optimize the load and increase the flexibility of the conventional sources. And when we are dealing with a lot of power but small energy, so this is the bottom right, is more about ensuring power system stability through frequency and voltage regulation. So Mondi talked about voltage regulation, which is very, very difficult, and storage can do something about frequency and voltage in that scale. I'll try to make a little zoom on the frequency regulation because there is many things that can be done. The good point of storage, and I mean, today there is already frequency regulation. I mean that all the thermal plants that are on the grids perform frequency regulations. The very big added value of storage is that it can provide those services with ultra fastness and ultra precision, and that's why that's a massive regulation for the grid utility. Is that there are in their hand a device that can provide a lot of value for frequency, and this is the purpose of the storage. I mean that with the BSS you can react much faster than a conventional power plant, which is we can react in milliseconds instead of seconds. So that's changed everything, because when we are dealing with frequency, the faster we are, the better for the grid. And this is the key point of storage. Just, I mean, to show you something that we did, and we are quite proud. I mean that we've got, for example, a project in Mauritius, in which the specification of the grid utility was to put some frequency regulation in less than 20 milliseconds, which was by far the fastest regulation on Earth in that time. And we did it. I mean, it's just about graphics, so don't worry about that. But it's just to show you that we managed to make the response in less than 20 milliseconds. And effectively, we did the response in 5 milliseconds, which is 1/4 of a phase. So that's tremendously fast. And thanks to that, we managed with very few power on the grid to really stabilize the grid of Mauritius Islands. So that's a key achievement. Something, I mean, it's just about 1/4 presentation, so I'm not going to ask about all the possibilities, but just to make a zoom about the major possibilities that we can do with storage. But just to give you an example, when we are dealing with storage and frequency regulation, the typical frequency regulation logic is what you can see on the left, in which I mean that you are going to provide some power. The more frequency deviation you have, the more power you provide. And this is what we call primary reserve. But thanks to storage and thanks to the addition of computer science in the regulation, you can make many other things. And just to give you one example that we perform, that the frequency regulation logics that we put in place is we put what we call an hysteresis. I mean that when the frequency is dropping down, you are going to inject a lot of power just to stabilize the grid. But when the frequency goes back, instead of decreasing the power, you continue to inject a lot of power. So that means that you are making a kind of secondary response in the same time. And thanks to that, you are able to help the grid stabilize and to get back to 50 Hertz or 60 Hertz, depending on the country. So this is something that is unique, because a typical thermal power plant can't do that. But with storage, you can do that, and that's a really key point. Just to put some examples, this is some examples of frequency regulation that we performed in the past, and you can see that thanks to the storage, we were able to really stabilize the power and get back to 50 Hertz, and this is what we expect from a grid utility. So this is one example, and the other one in which you can see that we've got the frequency drop, and then during let's say 5 minutes, we are still injecting the maximum power just to goes back to the dead band, and then we can close the frequency regulation. So this is some example. Now I'm going to speak about EMS modularity, just to show you what is possible to do when we are dealing with storage. So I'm not going to invent possibilities. I mean, we can do a lot of things, but I'm just going to show you what we already did in the past, just to show you that everything is possible, in fact. This one, for example, is the first project that we did in French Islands, in which, just to give you a little bit of context, there were too much solar energy in the grid, and the utility said above 30% of solar, I'm going to curtail all the new solar energy because there is too much on the grid, and going to make too much instability. So they decided to put some a new tender with solar and storage, and they said, okay, now what we expect with the storage is to be able to commit on the power profile the day before. I mean, and that power profile is what you can see in the graphic, is just to make a kind of trapeze, like you can see with a ramp up, a stable phase, and then a ramp down. And in the same time, you are going to make some frequency regulation and voltage regulation. So we did that. This is a project that is operating for more than 5 years, but that's very specific. And if we could say, okay, that's great. And so there might be a second tender or a third tender that is going to show the same specifications. But no, I mean, the second tender, just after, the guy said, okay, no, forget about what we did. Now we are going to put new specifications in which you're going to commit on a 1 minute data the day before with some updates during the very day. And by the way, you are going to have an obligation to store some capacity during the day to be able to inject power during the peak demand period at the night, because there is always some issues about peak demand on the night. So we did that, and it works. I mean, that's no issue. There is a lot of EMS engineering and so on. So we did that, and you can say, okay, that's okay. And the point is that the same utilities say, no, forget about this. I've got a new idea. We're going to make some wind, and we are going to make a commitment the day before on a 30-minute window, plus of minus 50%, 15% of the total power. So we put all the EMS to try to respect those windows of 30 minutes, just to be able to make some capacity funding of the wind energy. So if I summarize, you can see 3 examples: the first case, the second case, and the third case. So I mean, we can't make a poll, but I'd like to make a poll, because my question would be, what is the best strategy for the next 20 years? Is it the first case, the second case, or the third case? We can think about it, but I've got the answer. The answer is no one. No one. And why? It's just because it's impossible today to have a clear understanding about what is the best strategy for the next 20 years. Why? It's just because all the problematics of the grids are going to change in the next 20 years, because you are going to have a lot of new PV power. Maybe you have some decommissioning of coal plants and so on. Maybe you are going to upscale or downscale some grid lines. So everything's changed. So that's impossible to get a fixed functionalities for the next 20 years. So then I'll go to the key lessons from our experience during the last 10 years. And maybe with that, you may have a lot of questions, and I will be glad to answer to all those questions. So the first key lesson, use BSS in the right place for the right function. At that time, when we've been asked to put some storage to a solar, they were asking for many functionalities. And the point is that close to solar, there is some functionalities that are well suited and other functionalities that are not suited. And I just, in that table, trying to show you our understanding. What is adapted to a local scale is all about frequency regulation, because that's the same issue on the whole national grid. There is all about voltage regulations, because voltage regulation, it's a local issue and not a global issue. Then you've got some peak load management, because sometimes it's difficult to provide enough power during the night in a specific place. And what we call the midday curtailment. I mean, if you're going to have a lot of power in some place, you may have too much power, and you're going to exceed the capacity of the line during midday. And in that case, storage may help you to be able to inject more solar energy by decreasing the solar power at midday. And what is not adapted is all about daily commitments. I mean, that's nonsense to ask for a commitment on a 1 minute or 10 minute data profile for a solar plant, because the profusion of solar plants in the global area, like a country like South Africa, give you more smoothing that the production of one single plant. So that's I mean, there is no need to charge somewhere and discharge 10 kilometers away, because the clouds that was passing from one PV plant to the other PV plant, I mean, there is no sense. The same is about important smoothing. Asking for important smoothing, from our understanding, that's useless, because you are asking a lot of energy and it might be not useful. The same is about baseload. I mean, solar and wind is just about injecting a lot of power. You've got to have some storage to deal with that, but I mean, it's going to cost you far too much to use solar as a base load. And the last one is trying to perform use storage only for arbitrage. I mean, that for obviously arbitrage, it's relevant, but you can use storage for other purpose. And the point is that trying to mix different purpose. And one other thing that I'd like to raise today, we are, I mean, a lot of times we're trying to oppose all the renewable players with the what we call the conventional source players, like the coal plants and the gas plants and so on. And I think that's an error. I think that's an error, because I really think that the coal plants, for example, today are the best player, really the best player to lead the storage development. And why they are the best player? For 2 or 3 reasons. The first one is that the storage can really help to optimize the load rate of the thermal generator. And maybe, I mean, we're about, I mean, the whole world is about trying to decommission the coal plants. And the point is that I really agree on the people working in the coal plant saying, guys, I mean, that's an issue for me, because I'm not, I can't manage my plant like a pure flexible asset. I've got some difficulties to drop down, to ramp down, to ramp up my power, and I need help for that. And the storage can provide that help. typically, it's just rough figures, but typically the round trip efficiency for an energy battery, it's about 90%, something like that. And among those 90%, I mean, the lithium-ion battery, the efficiency is quite good. I mean, when we are talking about an energy battery, the DC conversion is just something like 98, 97%. Then you've got about 1 or 2% of losses with the PCS. You've got 1% of losses with the transformer. So you've got about 5%, and because this is a cycle, 5 plus 5 is 10%. So you are going to have a cycle efficiency of 90%. And because this is a system with a lot of energy and small power, you've got small losses. That mean that you don't need to cool the system a lot. So you're not going to have great losses of cooling. And this is not the case when you're dealing with a power battery. I would say that the efficiency that you may ask is something like 85, 84%. Why? Is just because the efficiency of the lithium ion itself, it's lower because you've got a higher power rate. And then because you're going to generate a lot of heat in the same place, you're going to need a lot of cooling systems that requires a lot of energy. And due to that, a power battery cycle efficiency is about 84%. So you are going to have a range between 84 to 90, depending on the duration of the battery.
Thank you very much, Julian. Does anybody else want to add comment to that? No? Okay, the next question, I'm afraid I'm going to take an executive decision on that. It's again about windmills and birds, and this session is particularly around energy storage. So I'm going to skip to the next question. Energy storage is a great solution. Do you think that prices of energy storage solutions, especially for solar, will become more affordable for businesses in the near future? I think maybe Kalyan, would you answer that, being a manufacturer of storage facilities here in South Africa?
Yes. Yes, I think it will become more affordable. It is already there is already signs of several financing companies which make up a better proposals to the businesses with finance PV plus energy storage than using the national grid. So they substitute partially and then also prevent from load shedding. So this already makes financial sense. And I think with decreasing of the price of energy storage, this will get only better.
Excellent. Thank you very much.
Terry,
sorry, Terry, it's Monday here. So I just to add or to also comment on this, the energy storage price issue. I think I saw the latest forecast that I saw, which I think it was by NREL. I can't remember exactly, but they were forecasting that the price of the energy storage actually is going to follow a similar curve to what the PV has been. So I think, as what has happened to the PV, we have it at large scale, we have it at small scale, we have it, so I think as soon as we open the market for battery energy storage, then obviously more manufacturers are going to start coming on board and they will compete, and then we'll end up seeing the prices going down. I think pretty much the same way we have seen the cell phone prices. If you remember what the price was in the 90s and what it is now, so that would be my guess. Thanks.
Excellent. Well, thank you very much. Gentlemen, could I ask you each now to give just some closing remarks from your side? May I start with Stephen, then Julian, Kalyan, and Mondi? I'll give you the last word. Stephen, would you like to give us your closing remarks?
Yes, absolutely. Thank you, Terry, and thank you to PV Box for the opportunity, and to all the presenters also from my side. Just from Goodwe's perspective, as an international company, headquartered in China, and looking at the various markets internationally, South Africa definitely poses a tremendous opportunity, as I clearly stated in my presentation. And Goodwe has already, in a very short time frame, seen the benefit of that opportunity that is available in the storage sector, and it's still very much early days opportunity too. So we definitely are foreseeing great things in South Africa and the African market in general. So yeah, that's it from my side, and feel very privileged to be a part of this fascinating industry and the growth.
Excellent, thank you very much. Julian, would you like to give us your comments?
Yes, of course. I would say that how do we say that? I'm so excited about what is coming to happen in the next 10 years. I know that when I started to work in renewable industry, my intention, my goal was to be able to have a viable system without subsidies. We struggled during 10 years to be able to do so. And right now, thanks to the great decrease of the cost of solar and storage, right now we've got a system that is viable. And what we are going to see in the next 10 years, maybe in the next 20 years, it's a complete revolution about the way we are going to be powered. And for sure, we know that that's an economical challenge, because there is a lot of movement, and that's difficult for everyone to handle those changes. There is going to be a lot of technical challenges, because all the grid has been shaped and sized for a system that was with big thermal plants and so on. So everything is new. We've got to be passionate for that, because we are on the edge of making a world really renewable, with not few panels just to show that we are happy with solar, but we are right now at the edge of the world in which we are going to have more than 50% of solar energy in the mix of every countries, and for sure, South Africa is one of the best countries for that, because you've got a very beautiful solar and wind resource. You've got a big economy in Africa, the biggest economy in Africa. That means that you can be really the leader in Africa to lead all that movement, and the commercial perspective for South Africa in the coming years are going to be great, just thanks to that possibilities.
Excellent. Thank you very much, and thank you for your interest in South Africa. It's sure good to hear about that. Kalyan, would you like to give us your closing remarks?
Yes. Sorry, I always need to unmute my microphone. So I just want to say thank you to PV Box and Energy Box for the great event. I think the discussion was very good, and I was very happy to have such a great technically and commercially co-speakers. And of course, all the attendees, I just thank you for attending this. Thanks.